Hello students, in today's class we will do the graphical representation of third law of motion. We have already done a graphical representation of first and second law. Today we will derive third law of motion from graphical representation. So let's begin. So here we have taken a velocity time graph. Velocity is in a y-axis and time is in x-axis. So this is the graph. It is a straight line graph which starting from a certain velocity u, which is the initial velocity, and the final velocity is v. Time taken to reach the final velocity is time t. So here OC is the time t, OA is the initial velocity, and OE is the final velocity. Now the distance traveled S. Distance traveled will be the trapezium or the area under the graph. So the area under the graph is the trapezium OABDC, or you can say OABC. So here S is equal to half into sum of sides into height. So we know that area of trapezium is half into sum of parallel sides, that is OA, into CB into height. Height is the OC. OC is the height. So half into OA plus BC into OC. Now OA means, as we know, O is the initial velocity u, so we have written u here. BC is the final velocity v, so we have written v here, and OC is the time t. This OC is the final time t. So also we know from the first law of motion that v is equal to u plus at. From here we will make t as the subject of formula. So t is equal to v minus u by a. Now S is equal to half u plus v into v minus u by a. So here we will take 2as, a and s, 2 and a will be multiplied in this side. So 2sa into u plus v into v minus u. So 2as is equal to, so we will write this v in front. So v plus u into v minus u. So this part becomes a plus b into a minus b form. So we will get b square minus u square. So we will make v square as the subject of the formula. So v square equals to u square plus 2as. Here we have arrived to the third equation or the third law of motion.